Dark matter, the invisible glue that holds the universe together. It's everywhere, yet we can't see it directly. For almost a century, scientists have been trying to uncover this cosmic mystery. Most of the matter in the universe is dark matter. Ordinary matter, the stuff that makes up stars, planets, and even Ewok counts for only about 5% of the universe. Dark matter makes up around 27%, and the rest is thought to be dark energy. Another cosmic mystery driving the expansion of the universe. So, if dark matter makes up so much of the cosmos, why can't we see it? The story begins in the 1930s. Astronomers noticed something strange. Galaxies weren't behaving as expected. Stars at the edges of galaxies moved so fast that they should have flown away. Yet, the galaxies stayed together. Swiss astronomer Fritz Zwicky studied a galaxy cluster called the Coma Cluster. He realized there wasn't enough visible matter to create the gravity needed to hold the cluster together. To explain this, he suggested there must be some invisible matter creating the necessary gravitational pull. He called it Dunkle Materie, or dark matter. For decades, this idea was largely ignored. Ordinary matter alone couldn't explain this. There had to be something unseen holding the galaxies together. Rubin's observations convinced the scientific community dark matter was real. Dark matter doesn't interact with light, but it does have mass, which means it affects gravity. Scientists study dark matter through its influence on ordinary matter and light. One key method is gravitational lensing. Massive objects like galaxies and clusters can bend the light from background objects. A famous example is the Bullet Cluster, formed when two galaxy clusters collided about 3.8 billion light-years away. During the collision, hot gas from each cluster interacted and slowed down, but the dark matter passed through almost unaffected. Observations from NASA's Hubble Space Telescope and Chandra X-ray Observatory showed that most of the mass mapped in blue was separate from the visible gas, providing some of the strongest direct evidence of dark matter. Scientists consider two possibilities: cold dark matter, made of slow-moving particles, or warm or hot dark matter, made of fast-moving particles. Simulations show that only cold dark matter can form the large-scale structures we see today, like galaxies and clusters. So, what could dark matter actually be? Scientists are exploring several possibilities. WIMPs, or weakly interacting massive particles, are hypothetical heavy, slow particles that interact mainly through gravity, which scientists search for using telescopes like NASA's Fermi Gamma Ray Space Telescope. Ixions are extremely light particles proposed in 1977 to solve a fundamental problem in physics. They could also explain dark matter. Scientists look for axion signatures in X-ray and gamma-ray data from telescopes like Fermi, Chandra, and NuSTAR. Primordial black holes are hypothetical black holes formed shortly after the Big Bang. They could range from tiny to massive, potentially contributing to dark matter. While these candidates remain unconfirmed, ongoing research continues to narrow down the possibilities. It's important to note that dark matter is not the same as dark energy. Both are cosmic mysteries, but they are fundamentally different. Mapping dark matter also helps scientists understand the effects of dark energy, giving insight into how the universe evolves. Studying dark matter is crucial because it forms the invisible scaffolding of the universe. It shapes galaxies, clusters, and the cosmic web. Upcoming missions, like NASA's Nancy Grace Roman Space Telescope, will map dark matter in unprecedented detail, helping scientists understand the universe's structure and evolution. Even though we can't see dark matter directly, we can observe its fingerprints across the cosmos. It's the invisible glue holding the universe together, shaping the cosmic story. And while much about it remains unknown, each discovery brings us closer to answering one of the biggest questions in science. What is the universe really made of? Dark matter may be invisible, but its influence is everywhere. And as scientists continue to explore, we are only beginning to glimpse the hidden side of the cosmos.